In this video, we will be looking at what happens to data as it passes through the four layers of the TCP/IP stack. Please don't forget to hit the subscribe button. This will keep you up to date with new videos. And also please hit the like if you like our video. So let's start with the application layer. So this is the very top of the TCP/IP stack, the four layers, and it uses protocols that relate to applications that transmit data. So such as HTTP, Hypertext Transfer Protocol, HTTPS, the secure version, FTP for file transfer protocol, moving files from a user's machine to a server. HTTP, as we already know, is used to retrieve web page content from web servers. So data is passed onto the transport layer from the application layer, and the application layer also receives data from the transport layer. So let's just try to get a visual interpretation of what that really means. So what I've produced here is a very simple diagram, node A and node B. So node A could be on one network, node B could be on another. So we have our four layers of the TCP/IP suite, and you'll notice that this is showing bidirectional data flow as the data makes its way down through the four layers. It makes its way across the physical network layer, and then it works its way back up the layer to be reconstituted into a format required for the application layer at the destination node. So obviously data flow would be bidirectional. Each layer will have an impact on the format. It will add data as it comes down the stack, and as it makes its way back up, the data will be stripped back off and reconstituted into a format required for the application protocol. So that little diagram hopefully will help your understanding. Now let's look at the transport layer. So this is below the application layer and above the internet layer. So it receives data from the application layer on the way down. As it's transmitting data, it will pass data back up to the application layer as it receives data. It uses the transmission control protocol to establish connections between the two nodes. Now, what this is used to do is to ensure that data is delivered. It's a guaranteed delivery method. So how does it do that? Data is split into packets, so the whole message will be cut down into smaller packets. Each packet will be given a number, and the total number of packets is also stipulated. Also, a port number will be allocated to packets, and that will help determine the data route. So for instance, the port number 80, that will be used by the HTTP protocol. So when we receive data packets at the destination node, an acknowledgement will be sent back to the sender to say, yes, I got packet number 1. If packets are not received, then the transport layer will request that that particular packet that wasn't received is retransmitted. So this is what gives us our guaranteed delivery method. So let's look at the internet layer now. Now, depending on which book that you read or which website that you're reading from, this can have various names. Sometimes known as the internet layer or the IP layer or the network layer, so it can be a little bit confusing. All of these terms are correct. So as we can see from my little diagram here, that it sits below the transport layer and above the network layer. It receives data from the transport layer as data has been transmitted and passes it down to the network layer. On receiving data, the internet layer will receive data from the network layer and then pass it back to the transport layer on the way to its destination. So this layer is responsible for adding IP, source and destination IP addresses. So the Internet Protocol will do that. Routers work at this layer. So we're able to establish whether data is to be routed through to another router as it goes through the internet. It also forms something known as a socket. Now, a socket is the combination of the IP address plus the port ID or the port number. So remember, port 80 is the common port used with HTTP protocol. Now let's look at the network layer, sometimes known as the link layer or network link layer. So this sits below the internet layer. So when data is being passed down from the internet layer to the network layer, it will then use the physical connection to pass data to the next step towards its destination node, and then the data will then be passed up to the internet layer at the destination. So this blue arrow here represents that we are physically sending data from node to node, from source to destination. It may require intermediary steps as it hits different routers on its path to the destination. Switches work with MAC addresses, so media access controllers. These are numbers that are programmed into network interface cards at manufacture, and they uniquely identify nodes on a network. So the MAC addresses are added to the packets, and it uses this MAC address to identify the network interface card on the network that you are sending data from and the target destination node that you are sending data to. So as we've said, MAC addresses are built into network interface cards. Now, the two simple types are you have wired network cards that you would find in desktop computers and wireless network interface cards that you would find in the likes of laptops, mobile phones, tablets. So a node, just to clarify what a node is, a node can be any device that is connected to the network, such as computers, printers, but routers will also be defined as nodes, as they can be an intermediary step as you pass data from one network to another. It will use the MAC address of the first router as its first step towards achieving its destination node. So that concludes our description of the 4 layers of the TCP/IP suite.